Hello friends, in this lecture we'll discuss one of the method of solving linear difference equations with variable coefficients. We have already seen the method of solution of linear difference equation with constant coefficients. Now we will see how we can solve the linear difference equation with variable coefficients. That is, if the coefficients of yt plus 1 up to yt plus n, if these are the variables or functions of t, variables or functions of t, not constants. Okay, so for this method is called variation of parameters method. Such method is also available in differential equation. In the differential equation also such method is available, but here parallel method is in the difference equation. Okay, so what this method says, if u1 up to un are linearly independent solutions of this homogeneous nth order linear difference equation with variable coefficients, then the solution of linear non-homogeneous difference equation with variable coefficients is given by y of t equal to a1t into u1t plus a2t into u2t plus up to plus ant into unt. Actually this is not ant, it is unt. Ant into unt is a solution of this non-homogeneous linear equation with variable coefficient, where a1 a2 a up to an satisfy this matrix equation. Satisfy matrix equation means what? A1 up to an are solutions of this system of n equations, non-homogeneous system of n equations in n variables delta ant up to delta delta a1t up to delta ant. How you can say that this is a non-homogeneous system of n equations? Because your this left hand side wt plus 1, this is actually Casortian matrix of Casortian. W of t plus 1 is matrix of Casortian. We know that what is meant by W of t? We know that W of t is given by the matrix nth order matrix u1t up to unt, first row, then second row u1t plus 1 up to unt plus 1, and in this way last row is u1t plus n minus 1 up to unt plus n minus 1. This is n by n matrix, this is n by 1 matrix, so again their product becomes n by 1 matrix, and this is also n by 1 matrix. If they equate, we get n different equations there, n equations there. What is wt plus 1 then? Only replace t by t plus 1 here. That is u1 of t plus 1 up to un of t plus 1 should be the first row. u1 of t plus 2 up to un of t plus 2 should be the second row, and so on. Nth row becomes u1 of t plus n up to un of t plus n. Okay, so this is the method. Means what this result says, to solve such type of non-homogeneous equation, if we know this n linearly independent solutions of homogeneous equation, then the solution of non-homogeneous equation can be obtained by using this formula, where a1 up to an can be obtained by solving this system of equations. Now we will prove this result for n equal to 2. That is for second order linear equations with variable coefficients. First of all, we will see or we will prove that the result holds for second order difference equations. And then we can um, uh, induct it for nth order. So whatever results are true for second order, same results will be there for nth orders. So to consider second order difference equation, so it must have two linearly independent solutions. Suppose that u1 of t and u2 of t be the two independent solutions of this second order homogeneous equation. We call it as equation number 1. Which equation is there? P2 of t, y of t plus 2 plus P1 of t, y of t plus 1 plus P0 of t, y of t equal to 0. So suppose that there are u1 and u2 are the two linearly independent solutions of this homogeneous equation with variable coefficient. Similarly, suppose that yt, which is given by a1 of t into u1t plus a2 of t into u2t, be the solution of corresponding non-homogeneous equation. Corresponding non-homogeneous equation means what? Only we have to take RT to right hand side. Consider equation number 3, where we will find a1t and a2t. Now, what is to prove here only? We have to show here now that only if this yt is a solution of equation 3, then a1t, a2t must satisfy such system. Now, if there are only two u1 and u2 second order, then what system becomes here? W of t plus 1 into delta a1t, delta a2t equal to right hand side means 0 and RT upon P2T. It should be there. That is A1T up to A2 satisfies this means what? What is the Cauchy matrix here? U1T, U2, actually it is T plus 1, U2T plus 1, U1T plus 2, U2T plus 2 into the same matrix equal to again same matrix. And what this implies? u1t delta a1t plus u1t plus 1 delta u1t plus 1 plus u2t plus 1 delta a2t must be equal to 0. And second thing is u1t plus 2 into delta a1t plus u2t plus 2 into delta ut must be equal to RT upon P2t. That is which this implies two equations. Which two equations? u1t plus 1 delta a1t plus u2t plus 1 delta a2t equal to 0. First equation. And second is u1t plus 2 delta a1t plus u2t plus 2 delta a2t equal to R of t upon P2t. So what we have to show for n is equal to 2, if yt is equal to a1t u1t plus a2t u2t is the solution of this equation, then a1t a2t must satisfy these two equations 1 and 2. Or also we can also say that if a1t and a2t are such functions which satisfies these two equations, then yt given by a1 of t u1t plus a2t u2t is the solution of this non-homogeneous equation where u1 and u2 are two linearly independent solutions of equation 1. We will prove this. So what we have considered, suppose that second order homogeneous equation, consider u1t and u2t are two linearly independent solutions of this homogeneous equation. Moreover, Again, suppose that yt, which is equal to a1t u1t plus a2t u2t, is the solution of non-homogeneous equation. Then we have only to show that if yt is a solution of this, then these two equations arises. Or if these two equations holds by a1 a2, then yt given by 2 is the solution of non-homogeneous equation 3. Okay, we'll prove that. Now suppose yt is equal to this one, you can find yt plus 1. But yt plus 1 becomes a1t plus 1 into u1t plus 1 plus a2t plus 1 into u2t plus 1. Correct? Now we will simply rearrange them. This a1t plus 1, u1t plus 1 as it is. Similarly, a2t plus 1, u2t plus 1, this term also as it is. We will add a1t, u1t plus 1 plus a2t, u2t plus 1, and we will subtract same term a1t, u1t plus 1 minus a2t, u2 plus 1. Adding same term, subtracting same term. So this is only rearrangement. Why we made this rearrangement now? That is, now I will keep as it is this one, a1t u1t plus 1 plus a2t u2t plus 1. First two terms as it is. Now we will convert these four terms into two terms. First of all, term third one and fifth one. If we see third and fifth, a1t plus 1 u1t plus 1 minus a1t u1t plus 1. From these two, u1t plus 1 is common and it remains a1t plus 1 minus a1t, that is delta a1t. So we get that term plus delta a1t into u1t plus 1 or u1t plus 1 into delta a1t, whatever it means. Plus, now we'll go for this one, fourth and sixth. a2t plus 1 u2t plus 1 minus a2t u2t plus 1, take u2t plus 1 common and we get a2t plus 1 minus a2t, that is delta a2 of t. So we get such type of equation, a1t u1t plus 1 plus a2t u2t plus 1 plus delta a1t u1t plus 1 plus delta a2t u2t plus 1. Now consider a1 and a2 such that delta a1t u1t plus 1 plus delta a2t u2t plus 1 equal to 0. That is this whole term. We will consider this term equal to 0. What will happen? Then our y of t plus 1 becomes only a1t u1t plus 1 plus a2t u2t plus 1. Hence yt plus 2 becomes a1t plus 1 replacing t by t plus 1 into u1t plus 2 plus a2t plus 1 into u2t plus 2. So let a1 a2 be such that equation number 4. Therefore yt plus 2 becomes a1t plus 1 u1t plus 2 plus a2t plus 1 u2t plus 2. This is u2t plus 2. Okay. Again rearrange as in the before. Adding a1t u1t plus 1 2 plus a2t u2t plus 1 and subtracting same term, keeping these two terms as it is, we get this one. Now again taking a1t u1t plus 2 plus a2t u2t plus 2 as it is. Now third and fifth term again gives, see here, a1t plus 1 u1t plus 2 minus a1t u1t plus 2. Take u1t plus 2 common, in bracket it will remains a1t plus 1 minus a1t, that is u1t plus 2 into delta a1t. Similarly here u2t plus 2 into delta a2t. So we get now a1t u1t plus 2 plus a2t u2t plus 2 plus delta a1t u1t plus 2 plus delta a2t u2t plus 2. So if a1 and a2 are such that delta a1t u1t plus 1 plus delta a2t u2t plus 1 equal to 0, then yt plus 2 is this one. Yt plus 2 is this one. Okay, it is like yt plus 2 is like this. So now Now put the values of yt plus 2, yt plus 1 and yt in equation 3 we obtain this p2t into yt plus 2. This is yt plus 2. p2t into yt plus 2, right? Plus p2t into yt plus 2. Correct? What is yt plus 2? a1t u1t plus 2 plus a2t u2t plus 2 plus delta a1t u1t plus 2 plus delta a2t u2t plus 2 plus p1t into, this is yt plus 1, a1t u1t plus 1 plus a2t u2t plus 1 plus p0t into yt, a1t u1t plus a2t u2t equal to rt. Okay, that is, now take a1t common from this term, a1t, this term and this term. We get a1t into p2t u1t plus 2 plus p1t u1t plus 1 plus p0t u1t. This one. a1t into p2t u1t plus 2 plus p1t u1t plus 1 plus p0t u1t. Similarly, take a2t common. We get p2t u2t plus 2 plus p1t u2t plus 1 plus p0t ut. And now plus remaining term, only this side, p2t delta a1t u1t plus 2 plus p2t delta a2t u2t plus 2. That is, if I take p2 outside, then we get only delta a1t u1t plus 2 plus delta a2t u2t plus 2 equal to rt. Now, since u1 and u2 are the solutions of homogeneous equation, therefore p2t u1t plus 2 plus p1t u1t plus 1 plus p0t u1t equal to 0. Similarly, p2t u2t plus 2 plus p1t u2t plus 1 plus p0t u2t is also equal to 0. Thus we get p2t into delta a1t u1t plus 2 plus delta a2t u2t plus 2 equal to rt. That is, delta a1t u1t plus 2 plus delta a2t u2t plus 2 equal to rt upon pt, equal to rt upon pt. Sorry, rt upon p2t. So as p2t not equal to 0. So what this equation obtained? This implies that if yt is a solution of non-homogeneous system, if yt is a solution of non-homogeneous equation where a1t and a2t satisfies 4 and 5, 4 means this is a 4, 4 and 5, 4 and 5, right? We can, and this we have to show. Thus, if 3 and 4 satisfies, then yt given by 2 is the solution of 3. If 3 and 4 not, if this 4 and 5, we call it as, if 5 and 4 satisfies, then yt given by 2 is the solution of equation 3. What 4 and 5 are there? What 4 and 5 are there? 4 is this one. 4 is this one. Which one is 4? Yes, delta, this one. Delta a1t u1t plus 1 plus delta a2t u2t plus 1. 4 is what? Delta a1t u1t plus 1 plus delta a2t u2t plus 1 equal to 0. And second equation, delta a1t u1t plus 2 plus delta a2t u2t plus 2 equal to rt upon p2t equal to, so if u1t u2t satisfies these two equations, then yt given by a1t plus into u1t plus a2t into u2t is the solution of non-homogeneous. And what about this? Can I write this in the matrix form? u1t plus 1 u2t plus 1, first row, u1t plus 2 u2t plus 2 second row into matrix delta a1t delta a2t equal to matrix 0 rt upon p2t. So what we proved? If a1t a2t satisfies this equation, system of equations, then yt given by a1 u1 plus a2 u2 is the solution of non-homogeneous equation, where u1 and u2 are the solutions of homogeneous equations. Okay, so this is the result for second order difference equation. Result for second order difference equation. Okay, result for second order difference equation. Hence, if it is true for second order, it should be true for nth order also. Okay, it should be true for nth order also. We have one corollary from for this. The unique solution yt of equation p2t yt plus 2 plus p1t yt plus 1 plus p0t yt equal to rt, satisfying y at a equal to y at a plus 1 equal to 0 is given by the variation of parameter formula yt is equal to summation from k is equal to a to t minus 1 u1k plus 1 u2t minus u2k plus 1 u1t upon p2k w of k plus 1, right, into r of k. Now this is a small w for determinant, capital W for matrix. Keep in mind this. Small w for determinant. So what about this? This is the initial value problem, because the values are given at a and a plus 1. You know that your interval is what? A to b plus 2, like this. A to b plus 2. So a is a first value, a plus 1 is the second first value. So a and a plus 1 are the values lies at initially lies. Therefore these are called initial value problem. Many times we confuse in what is meant by boundary value problem and initial value problem. If such conditions are given at boundary points, not 2 points, given at, suppose here y at a equal to 0 and y at b plus 2 equal to 0, if such thing is given, then we say that it is boundary value. So if conditions are given at boundary points, then it is called boundary value problem. If conditions given at initial point, then it is called initial value problem. Okay, so if we know the solution of if we know the conditions, then we can find it's a solution of initial value problem. As well as you should know u1 and u2, that is two linearly independent solutions of homogeneous equations, where u1 and u2 are independent solutions of equation. This is corresponding homogeneous equation. What is it? This is just corresponding homogeneous equation. Now we will prove it. How you can say that yt is given by k from 1 to a to t minus 1 u1 k plus 1 u2 k t minus u2 k plus 1 u1 t upon p2 k w of k plus 1 into r of k. How this becomes solution of non-homogeneous equation satisfying these conditions. So how you can prove it? See whether this equation is satisfied or not, whether it becomes r of t or not. Let a1 t equal to summation from k is equal to a to t minus 1 rk u2 k plus 1 upon p2k into w of k plus 1, and a to t is equal to summation k from a to t minus 1 rk u1 k plus 1 upon p2k w of k plus 1. How you can say now here a1t is like this and a2t is like this? Again it is a solution of this system. What first equation we get? Delta a1t, right, into u1t plus 1 plus delta a2t into u2t plus 1 equal to 0, and second is what? Delta a1t u1t plus 2 plus delta A2t U2t plus 2 equal to RT upon P2t. Now solving these two equations simultaneously, how we get? So how you can find delta A2t and delta A1t? From this, we know that delta A1t is given by determinant. First column will be replaced by 0 RT upon PT. 0 RT upon PT. E2t here. And second column is what? U2t plus 1 and U2t plus 2 divided by determinant of coefficient. What is it? U1 of t plus 1. First row U2 of t plus 1. Second row U1 of t plus 2. U2 of t plus 2. Which is equal to the cross multiplication. 0 into this one. 0 itself. Only we get minus U2t plus 1 into RT upon P2t. U2 minus U2t plus 1 into RT upon P2t divided by, what is it? This is simply small w of t plus 1. Can I write this as minus U2t plus 1 into RT upon w of t plus 1? What is it? This is delta A1t. Delta A1t. What will be A1t now? What will be A1t? A1t is just, what is A1t? This implies A1t equal to just summation of this one, and if I write this summation into definite, so it will get k from something a to t minus 1 minus of this term as it is, minus of k from a to t minus 1 rk u2k plus 1 upon p2k w of k plus 1. Here it is rk, t is replaced by k, rk u2 k plus 1 divided by p2 is here, this p2 is here, p2k, here it is t, but if I write in definite form, it becomes p2k w of k plus 1, which is a1. Similarly, a2 we can obtain by using same thing. We know that in first row only replace this by, so first column becomes a1t, u1t plus 1, u2t plus 1, and only this column will be replaced by r0 rt upon p22. And so again you will get a2t equal to summation k from a to t minus 1 rk u1k plus 1 upon p2k w of k plus 1. No doubt it is small, that is Casortian at k plus 1. Okay, so a1t is here, a2t is here. Okay, a1t and a2t. Now, therefore delta a1t, that you have obtained. Delta a1t is a1t plus 1 minus a1t. Again you are finding same thing which is already there. See there, which is this one. You already found this. No need to obtain. This is your delta a1t. This is your delta a2t. So delta a1t is minus rt u2t plus 1 p2t w of t plus 1. Delta a2t is rt u1t plus 1 p2t w of t plus 1. Thus delta a1t u1t plus 1 plus delta a2t u2t plus 1 becomes, so multiplying this by a1t u1t, this one, multiplying this by u1t plus 1 and second by u2t plus 1, we get minus rt u2t plus 1 upon p2t wt plus 1 u1t plus 1 plus this one. Then both terms are there, which is equal to 0. So your delta a1t u1t plus 1 plus delta a2t u2t plus 1 equal to 0. That means u1 u2 satisfy that condition. Similarly, delta a1t u1t plus 1 u1t plus 2, if I multiply this by u1t plus 2 and this by u2t plus 2, the calculation shows it is minus rt upon p2t. Thus yt is equal to a1t u1t plus a2t u2t. R is the solution of that equation. But what is a1t into u1t plus a2t into u2t? a1t into u1t plus a2t into u2t. What is u1t? U1t we have obtained, minus summation from t is equal to a to t minus 1 rk u2k plus 1 upon p2k w of k plus 1 into u1t plus this is a to t into u2t. Here it is not k, it is here u2t is the solution. What we want to show? This we want to show. We need to show this one because denominator is same for this both, right? This p2k wk plus 1, p2k wk plus 1, only this is in plus sign, this is in minus sign. Okay, so yk which is equal to this is the solution of that equation. Even we don't want to verify these conditions, two conditions, no, because directly from that theorem we get this one, a1t we get, a2t we get. Okay, so by taking a1t and a2t, so directly you can say that as a1t is delta a1t is this one, no doubt, as delta a1t is equal to this one, therefore this implies a1t equal to this term, right? A1t equal to this term. Similarly, as delta a2t from this solution, again by using previous theorem, that's why it is corollary, then your a2t, this implies a2t equal to this one simply. So multiplying, so therefore yt becomes a1t into u1t plus a2t into u2t. Just multiply first term by u1t, second term by u2t, you will get this term. And after simplification, as denominator is same, there is a summation, second term have taken firstly, first term have taken secondly, you will get this whole term. And rk is common in again numerator, so rk is common. Okay, that is it. Now we will solve some examples by using this variation of parameters. So find all the solutions of yt plus 2 minus 7yt plus 1 plus 6yt equal to 0. Let us solve. Now this is the, no doubt, this is the equation with constant coefficient. Okay, that can be solved by using variation of parameters. So corresponding homogeneous equation is this one. Ut plus 2 minus 7ut plus 1 plus 6ut equal to 0. This is the corresponding homogeneous equation of given equation 1. Then it's a characteristic polynomial e square minus 7e plus 6 and characteristic equation is e square minus 7e plus 6 equal to 0. So this can be factorized and you can write e minus 1 into e minus 6 operating on ut equal to 0, and therefore 1 and 6 are the two characteristic solutions. Therefore 1 to the power t, 6 to the power t are two linearly independent solutions of that equation, equation number 1. So u1t is equal to 1, u2t is equal to 6 to the power t are linearly independent solutions of 1. Now we have to find its a particular solution equal to t ka solution equal to t. So once you know u1t, u2t, let a1t and a2t be such that these two conditions are satisfied. That is delta a1t u1t plus 1 plus delta a2t u2t plus 1 equal to 0. And second condition is what? Delta a1t u1t plus 2 plus delta a2t u2t plus 2 equal to RT upon P2T. What is RT here? RT means right hand side of non-homogeneous equation. And what is meant by P2T? P2T is the coefficient of yt plus 2. What is P2T here? It is 1. What is RT here? T. So T upon 1. So only we get T. So delta A1T into what is U1T? U1T is 1. What is U1T plus 1? It is again 1. So no need to write. Plus delta A2T. What is u2t? 6 to the power t. u2t plus 1, 6 to the power t plus 1 equal to 0. Second equation, delta a1t plus, again, u1t plus 2 is also 1, as ut is 1. u1t plus 1 as u1t. This is not ut, this is u1t. So as u1t is 1, u1t plus 1 is 1, u1t plus 2 is also 1. As u2t is 6 to the power t, u2t plus 1 becomes 6 to the power t plus 1, and u2 t plus 2 becomes 6 to the power t plus 2. Okay, so we get this one 6 to the power t plus 2. Hence, by using Cramer's rule, which rule we are using here? Cramer's rule. So delta a1t is equal to determinant your coefficients of these 1 1, these should be replaced by 0t, so 0t, and coefficients of these 6 to the power t plus 1, 6 to the power t plus 2, that is 6 into 6 to the power t and 36 into 6 to the power t, divided by determinant of coefficient, first column 1 1, second column 6 to the power t plus 1, 6 to the power t plus 2, equal to this cross multiplication 0 minus t into 6 into 6 to the power t. So minus 0 minus 6 into t into 6 to the power t. Okay, divided by 1 into 6 to the power t plus 2, that is 36 into 6 to the power t minus 6 into 6 to the power t. So we get minus 60 6 to the power t divided by 36 minus 6, that is 36 to the power t. 6 5s are 30, 6 to the power t cancels with 6 to the power t, and you get delta 1 a1t as minus t by 5, minus t by 5. Similarly, delta a2t, first column 1 1, second column replaced by right hand side 0t, and denominator is same, which is this one, as the answer of this is 30 into 6 to the power t, which will remain same, 30 into 6 to the power t. Now this cross multiplication, t minus 0, so t upon 30 into 1 by 6 to the power t, 6 to the power minus t, or this is 1 to the power t upon 6 to the power t, that gives 1 upon 6 to the power t, 1 upon 6 to the power t. Therefore, now what is a1t? a1t is your minus t by 5. So your a1t, delta a1t is minus t by 5. So a1t becomes summation of minus t by 5 plus arbitrary constant c1, which is equal to, as minus t means what? It is t to the falling 1. So its a summation gives 1 by 5 as it is, minus 1 by 5 as it is, summation of t to the falling 1 is t to the falling 2 upon 2. So 5 to 10. So minus t to the falling 2 upon 10 plus some arbitrary constant c1. Similarly, as a2t is t by 30, 1 by 6 to the power t. So delta a2t is this one. So your a2t becomes summation of t by 30, 1 by 6 to the power t plus some other arbitrary constant c2. So 1 by 30 common, means outside the summation you can say here summation of t into 1 by 6 to the power t plus arbitrary constant c2, which is equal to 1 upon 30. Now you have to use summation by parts here. First, as it is, t as it is, summation of this term. Summation of 1 by 6 to the power t is 1 by 6 to the power t upon 1 by 6 minus 1, minus, in summation, the summation difference of first term 1 into summation of second term, and it's a shift operator, EUT is there. So 1 by 6 to the power t upon 1 by 6 minus 1 is the summation, and t is replaced by t plus 1. So 1 by 6 to the power t plus 1 upon 1 by 6 minus 1 plus some arbitrary constant c2. So 1 by 30 is common in both these. Okay, these two common. So 1 by a to t, 1 upon 30 into, now what about 1 upon 6 minus 1? This gives minus 5 by 6, and if we take into multiplication, it gives minus 6 by 5t, 1 by 6 to the power t, plus, what about here? Again you will get, what you will get here? This is your minus 5 by 6. This will comes here minus 6 by 5, and this minus plus 6 by 5 into summation of 1 by 6 to the power t plus 1 now. Or what about this here? What you are getting here? This is your plus 5 by 6 into summation of 1 by 6 to the power t plus 1. That is, if I take 1 by 6 outside, we get 5 by 36 into summation of 1 by 6 to the power t. What is that summation? 5 by 36 into again 1 by 6 to the power t upon 1 by 6 minus 1, that is minus 5 by 6. 5 cancels with this 5, 6 6 are 36. But you will get totally this 6 by 5 into this one, 1 upon 6 into 1 upon 6 to the power t minus 6 by this one plus c2 plus c2. So what you will get? Minus 1 upon 6 6 cancel. Okay, minus this one is no, this is 6 by 5, not 5 by 6. This one is minus not. This is 6 by 5 here. Okay, 1 minute. Huh? What about this? Summation of minus 6 by 5 into 1 upon 6 to the power t plus 1. This is there, which is summation of minus 6 upon 5 into 1 upon 6 into 1 upon 6 to the power t. So it is 1 by 5. Okay, minus minus plus 1 upon 5 into, again you will get 1 by 6 to the power t upon minus 5 by 6. So this gives something 6 upon 25. So this one is there. Okay, plus arbitrary constant c2. And therefore, if I solve it, we get minus 1 upon 25t, 1 by 6 to the power t. This is a1t, u1t, a1t, u1t. What is a1t? Minus t to the falling 2 upon 10 plus c1. a1t. 1 minute. a2t is this one. Okay. Okay. Right. Thus a1t, u1t plus a2t, u2t. So just this is a1t, u1t is 1, a2t, u2t is 6 to the power t. It is just solution there. So after this solution, you will get c1 plus c2 6 to the power t minus t square by 10 plus 3 to the power t by 50 minus 1 upon 125, that is a plus b into 6 to the power t minus t square upon 10 plus 3t upon 50 is the general solution of given difference equation. It is a general. These are more. This is also one more example which we can solve. This is also one more example. So which example is here? We'll add one more. Okay. Where it is added? I think it is added in initially. Okay. We'll make new file here. This one. Which example we want to solve here? Last example for this one. Okay. Yt plus 2 minus 7yt plus 1 plus 10yt equal to 4 to the power t. Yt plus 2 minus 7yt plus 1 plus 10yt equal to 4 to the power t plus 10yt equal to 4 to the power t. This is the given equation. The corresponding homogeneous equation becomes u of t plus 2 minus 7 u of t plus 1 plus 10 ut equal to 0. This is the corresponding homogeneous equation. Now this can be written as e square minus 7e plus 10 operating on u of t equal to 0. That is, this can be written as e minus 2 into e minus 5 operating on ut equal to 0. And therefore this implies u1t equal to 2 to the power t, u2t equal to 5 to the power t are linearly independent solutions of equation 2. Okay. Now let u1t, u2t, sorry, a1t, a2t be such that a1t, a2t be such that delta a1t into u1t plus 1 plus delta a2t into u2t plus 1 equal to 0 and delta a1t into u1t plus 2 plus delta a2t into u2t plus 2 equal to RT upon P2T. That is, now what about u1t plus 1? u1t is 2 to the power t. What is u1t plus 1? 2 to the power t plus 1 into delta a1t plus u2t plus 1 is 5 to the power t plus 1 into delta a2t equal to 0. Second, u1t plus 2. Now 2 to the power t plus 2 into delta a1t plus 5 to the power t plus 2 into delta a2t equal to RT upon P2T. What is RT? Right hand side of that 4 to the power t. Upon what is P2T? P2T is the coefficient of yt plus 2. It is 1 again. 4 to the power t upon 1. This implies a1t is equal to, sorry, delta a1t is equal to determinant. First column is replaced by 0, 4 to the power t, and second column is 5 to the power t plus 1, 5 to the power t plus 2. Denominator is determinant of coefficient 2 to the power t plus 1, 2 to the power t plus 2 first column, 5 to the power t plus 1, 5 to the power t plus 2 second column, which is equal to, this becomes 0 and this becomes minus 4 to the power t into 5 into 5 to the power t divided by, this becomes 2 into 2 to the power t into 25 into 5 to the power t minus 5 into 5 to the power t into 4 into 2 to the power t, which is equal to, now what this gives, 5 into, this is minus 5 into 4 to the power t into 5 to the power t divided by, now what about this, 25 into 2, 50, 2 to the power t, 5 to the power t minus 20 2 to the power t, 5 to the power t. So this becomes 30, 2 to the power t into 5 to the power t, which is equal to minus 1 upon 6. Now 5 to the power t cancels with power 5 to the power t. Here we can write it as 2 to the power t into 2 to the power t. 1 cancels with 2 to the power t. We get only 2 to the power t. This is delta A1t. So this implies A1t is equal to summation of minus 1 upon 6. So minus 1 upon 6 2 to the power t plus in C1, that is minus 1 upon 6 into 2 to the power t upon 2 minus 1 is 1 plus C1 equal to minus 2 to the power t upon 6 plus C1. Similarly, delta A2t becomes, now this first column is as it is, that is 2 to the power t plus 1, 2 to the power t plus 2. Second column will be replaced by 0, 4 to the power t, and divided by, that will be as it is, this term here will be as it is, 30 into 2 to the power t into 5 to the power t equal to, now this multiplication becomes 2 into 2 to the power t into 4 to the power t upon 30 into 2 to the power t 5 to the power t. This will give, now what about, this will give us, now 2 to the power t cancels with 2 to the power t, 2 by 30 means 1 upon 15 into 4 by 5 to the power t, and therefore this implies A2t is equal to 1 upon 15 into 4 by 5 to the power t, that is summation, upon 4 by 5 minus 1 plus something C2. This gives 1 upon 15 into, what about here, what you will get, 4 by 5 minus 1, that is minus 1 by 5, and here it will be in product, it is minus 5, 4 upon 5 to the power t, which gives us minus 1 upon 15, right, 4 by 5 to the power t plus something C2, and thus yt gives A1t U1t plus A2t U2t equal to, what is A1t now? A1t is minus 1 by 6 2 to the power t plus C1 minus 1 upon 6 2 to the power t plus C1 into, what is U1t? U1t is 2 to the power t plus A2t is minus 1 upon 15 4 by 5 to the power t plus C2 into U2t. What is U2t? 5 to the power t. U2t is what? 5 to the power t. So now what we'll get? So this gives us, what about this? Minus 1 upon 6 into 4 to the power t plus C1 2 to the power t minus, right, minus 1 upon 15. Now 5 to the power t cancels with 5 to the power t, 4 to the power t plus C2 into 5 to the power t, which is equal to C1 2 to the power t plus C2 5 to the power t. Now 40 to the power t as it is, minus 1 by 6 minus 1 by 15. What we get there? If I take 30 as LCM, 15 2s are 30 is LCM. So this becomes 5 plus 3, 30, 5 plus 2, not 3. 6 5s are 30, 15 2s are 30, right, into 4 to the power t, which will give us C1 2 to the power t plus C2 5 to the power t minus 7 upon 30 4 to the power t is required solution. Okay, this is the required solution. In this way, you can find the solution of a non-homogeneous difference equation by using variation of constant formula. Okay, so these are the methods to solve these equations there. Okay, by using which method? Variation of constant formula. For this we will stop here.